Hello students, this is the first lecture on chemical bonding and the molecular structure. This is the first lecture. In this lecture we will going to understand what we are going to learn from this chapter, and this is basically focused on the class 11 chemistry chapter. In this chapter we will going to understand basically all the theories that has been put forward over a period of time, different types of theories that we are going to learn, and relating all those theories we will understand other things like polarity of the bond, like all the things that we are going to understand. We know this is a very simple thing that matter is made up of different type of elements, and it is a very surprising thing that no element exists in the normal temperature, the normal conditions as atom in the nature, except the noble gas. The group of atoms is found to be existed as a single species having the characteristics properties. This group of atoms is called the molecules that we already know. As for example, H2O. In the H2O that you will find, this is in the H2O you will observe that one hydrogen atom, two hydrogen atom and plus one oxygen atom has been grouped. This is the group of atoms has been staying as a together, and this is a single species, and it can be easily understand. It is obvious that all these atoms in the molecules, you need some binding forces between them, and these attractive forces or binding forces of the constituents in the chemical species, different chemical species, is called the chemical bonding. So we can write the definition of the chemical bonding is like this way. Chemical bonding is basically it is the attractive forces. It is so we can define the chemical bonding. It is the attractive forces between the constituents. The constituents may be atoms, may be ions in different species to keep them together. This is called the chemical bonding. Now, there is a lot of question arises when the elements, different elements has been combined and it is going to produce different types of compounds. Different type of questions. First question, that is the very important question, that is why atom combine. We already understand the element do not exist as atom. So question arises why atom combines, and then we can understand another question that is come to our mind, that is why there is a definite combinations. Definite combinations means that when we are talking about H2O, it is always H2O, not otherwise. And another questions, that is why and molecule where a molecule having a definite shape. Molecule having definite shape. So all these questions arise in the minds of the scientist, and to find out the solution of these questions, there is different types of theories put forward over a period of time, and that you can see all those theories. First theories is Kossel, these four theories put forward over a period of times. And you can understand one thing, all those theory has been evaluated and the interpretation of the bonds has been developed in the direction of the development of the knowledge of the atomic structure and the electronic configuration of the elements and the periodic table. All those things has evolved all these theories. That is, first we can see Kossel-Lewis approach. Second, the valence electron pair repulsive theory. Third, that is valence bond theory. And fourth, this is molecular orbital theory. In this chapter, we are going to discuss all those theories in details and how they are going to help us to explain the chemical bonding in different ways. So, in this lecture, we are going to discuss this Kossel-Lewis approach towards the chemical bonding. So, today's lecture is basically on the Kossel-Lewis theory. And it is also called the electronic theory of chemical bonding. We can also call it a electronic theory of chemical bonding. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. So, Kossel-Lewis theory that we are going to discuss today. Many scientists tries to explain the bonding between the atoms in terms of the electrons, but it is 1916 that two scientists independently give a successful explanation regarding this atomic bonding, and that is based on the inertness of the noble gases. The theory is based on the inertness of noble gas. And they proposed a very important thing, both of them, that every atoms wants to achieve the valential electronic configuration as like the inert gas. Inert gas having the valential electron configuration is NH2Np6, and in this way every atom wants to achieve that, and for that they are going to bonding with themselves, and this achievement of this your outside cell electronic configuration is only possible by two ways, that is, one, transferring of the electrons with each other, and other, that sharing of the electron with each other. So first we will understand how the transferring of the electrons from each other is going to produce the chemical bonding, and this chemical bonding is called the electrovalent bond. This is the electrovalent bond, and the property is called the electrovalency. So first we are going to understand the Kossel theory. Kossel theory is basically on this point. Kossel theory. The main points of the Kossel theory is number 1 point, that he says in periodic table highly electronegative elements The main points of the Kossel theory: first, in the periodic table, the highly electropositive elements, or we can say highly electronegative elements, halogen, and the highly electropositive element, alkali metal, is separated by the noble gas. That you already know. In the periodic table, there is group number 17, there is a halogen, then noble gas in the group number 18, and group number 1 there is a alkali metals. And the generation of the positive ion from the electropositive element, that is metal, is by losing the electron, and the generation of the negative ion from the electronegative element, that is the halogen, by gaining that electron. And in this process, what we find, that when it loses or gain the electrons, the outside shell, valence shell's electron configuration of the atom, when it is formed, ion has been formed, has achieved the octet of electrons, and this is called the octet rules. You know that one thing, that the electronic configuration of the valence shell electronic configuration of the noble gas is 8. That is, we already understand this is the electronic valence shell electronic configuration, that is, it is having the number of electrons is 8, and that has been achieved by losing or gaining the electron by the atoms itself. And after that, when this positive ion and negative ion has been produced, and these ions, positive charge and negative charge, will be stabilized by the electrostatic force of attraction, and this ionic product has been produced, and that is the Kossel theory. So we can take one example, formation of sodium chloride, suppose. In this case, what is going to happen first? Na will lose the, sodium will lose the electron, and it is become the Na plus positive ion, and this chlorine will gain this electron, what is being donated by the sodium, it is gained by the chlorine, and it is become Cl minus. And after this, what is going to happen? And in this case, let us write how it achieve the electronic configuration. That is, electronic configuration of the sodium, that we know, that is, it has a neon core, and in the outside it will have the 1 electron, and it is become the neon, which is the electronic configuration of the sodium plus ion. And for the chlorine, you will see that it will accept 1 electron, this electron, and it is having the electronic configuration of neon core and 3s2 3p5. It's the valence shell's electronic configuration of the valence shell, and when it's gain this electron, and its electronic configuration will be Na and 3s2 3s2 3p6, and it is basically the argon, electronic configuration of argon. So by losing sodium lose the electron, and it will become the configuration of this outside shell configuration as like your neon, and whereas in the chlorine itself you can say it is become a electronic configuration like argon, that is noble gas. After that, what is going to happen? These two, chlorine and neon, will be NaCl will be produced. After this, you can write Na plus Cl minus is equal to NaCl. So in this process, this bond is called the electrovalent bond. The bond has been produced, the attractive forces due to the positive charge, creation of the positive charge and negative charge, and this attractive force, the bonding due to this attractive force is called the electrovalent bond. So we can write this is electrovalent bond. And there is another term that we need to learn, that is the electrovalency. Here number of ions, electrons has been transferred, that is 1. So this will call the electrovalency is will be for sodium it is plus 1, and for chlorine it is minus 1. Electrovalency for sodium it will be plus 1, and for chlorine it will be minus 1. So this is the electrovalent bond, and we will take another example. That is another example, that is calcium fluoride. Suppose calcium will lose 2 electrons, and its electronic configuration is argon core and 4s2, and when it release this 2 electron, it is become the its valence shell's electronic configuration will be like argon, and we have taken the 2. Now we are taking the fluorine atom, and this fluorine atom will take up 1 electron, so it will become this, and fluorine having the electronic configuration of the helium core with 2s2 2s5, and it is become the helium core and 2s2 2p6, or it is neon core. So in this process we can understand one thing, that in this transference the electron form this electropositive element. This is the electropositive element, and it is the metal element, and it will liberate 2 electrons, and it will become Ca plus 2, and it's the 1 electron each transferred to the 2 fluorine atoms, and it is, you can write this 2 fluorine atom 2 2, and it is become the calcium fluoride. So in this case the electrovalency for electrovalency to say for the calcium it is plus 2, for the fluorine it will be minus 1. So we understand what is electrovalent compound, what is electrovalency. Now we are going to discuss what are the factors governing the ionic bond or electrovalent bond. So these things we are going to understand now. The factors governs the ionic bond, or this is also called electrovalent bond. There are basically 2-3 factors that we are going to discuss. Number one, the low ionization enthalpy. Number two, high electron gain enthalpy. And third number point, that is the high lattice enthalpy. These three things that are going to influence the ionic bonds. The two elements that are going to form this ionic bond, one element should be electropositive, and normally this is the metal elements, and another elements that will have the highly electronegative property that it can easily attract the electron. This will have the high electron gain enthalpy. For this low ionization enthalpy, that you have to release this electron easily. Ease of formation of the cations or ease of formation of the anions will be the basic criteria for producing the electrovalent bond. But apart from these two, another very important thing, that is the high lattice enthalpy. Because ionic compound, when it's produced, it will become a solid compound. Basically, ionic compound in the room temperature, it is a solid. So this solidification or this type of structure only been achieved when there is a release of the energy from the ions in the gaseous state. It will going to produce a structure regular molecules. Structure that is called the crystal lattice, that we will understand in the class 12 chapter, that is the solid state, and that in that chapter we will understand it on detail. But you understand here that how high lattice enthalpy favoring the formation of the ionic bond. The high lattice enthalpy means when the cations and anions combine, it will form a structured compound. As for example, NaCl, you can see that here the formation of these cations and arrangement of the cations and anions, they will be in the very structured fashion. And for this you need the lattice enthalpy. And lattice enthalpy should be as high as possible. Means when sodium and chlorine is combined, and it will have to liberate the energy, heat will be released. After that, this lattice will be prepared. Lattice is basically the regular arrangement of the cation and anions, and it depends on the which type of ionic compound we are going to produce. So higher will be the lattice enthalpy, higher will be the chances of producing of this ionic compound. Now lattice enthalpy depends on the two factors. Number one, that is the charge on the cations and anions. Charge on cation, number one. Number two, the size of the lattice enthalpy. Lattice enthalpy depends on number one, that is the charge on cation or anion. Cation or anion. Number one. Number two, the size of the cation or anion. Higher the lattice enthalpy, higher will be the force of attraction between the cation and anions. So we can write this force, attractive force, F is equal to Q1 by Q2 by R square. R square, it is the distance between the cations and anions. And either Q1, Q2 is the charge of this. So higher the charge means higher will be the attractive force and higher will be the lattice enthalpy. Higher and distance, lower the distance, lower the distance means higher will be the lattice enthalpy. That you can see it is inversely proportional to the distance of between the charges. So these two factors that is going to govern the lattice enthalpy, that is the first charge factor and then size of the factors. As for example, lithium fluoride. Lithium fluoride will be having the less lattice enthalpy than your calcium fluoride. And calcium fluoride will be less lattice enthalpy than magnesium sulfate. So you can see the charge is increasing, so the lattice enthalpy goes on increasing. And these things that is for the charge factor, the lattice enthalpy has been influencing. Then the size factor. Size factor, you can see lithium fluoride will have the higher lattice enthalpy than the lithium iodide. Why? The iodine has the higher size than the fluoride. And similar fashion, you can see lithium fluoride will have again greater than the cesium fluoride, because here the charge size of this cation goes on increasing, and in this way the lattice enthalpy going to be influenced. Okay, and higher the lattice enthalpy, that will again also going to create problem when we try to dissolve it in the water. Higher the lattice enthalpy and it is higher than the hydration enthalpy, then the material will not going to be dissolved. You can see different fluids are not, in spite of the ionic solid, they will not able to dissolve in the water because of the fact they have the lattice enthalpy is higher than the hydration enthalpy. Okay, so in this lecture we have completely discussed what is included in your syllabus, that is the electrovalent bond, and that is given by the Kossel. That it is basically the bonding between the charge particles, that is the cations and anions, and it is basically the electrostatic force of attraction. And we also understand in this lecture that how the ionic bonds has been produced from the different elements, and the two elements that is going to take part in this bond formation one must be the electropositive, other will be electronegative. And we also understand how the factors, because this is the three factors we have discussed. One, the atoms will be the low ionization enthalpy. Number two, high electron gain enthalpy, and number 3, high lattice enthalpy, going to favor the formation of the ionic bonds. Okay, that is all for today's lecture. Next lecture we will discuss the Lewis approach, that is the covalent bond, and also we will discuss the Lewis-Langmuir theory, Lewis symbols and Lewis structures. And in that video we will also discuss about the drawbacks of the octet rule, that we will already understand in this lecture. What is octet rule? It is basically every atom try to achieve the 8 electrons, octet of electrons in the valence shell. This is basically the octet. Thank you very much for watching this video, and we will meet in the next video. Thank you.